Hi everyone. Today I'll be discussing about Netflix movie recommendation system. These are the table of contents which can be used to navigate to the appropriate slide. Netflix, as we all know, we use this platform to watch different movies and series every day. Currently, Netflix has its own movie recommendation system in place, which is known as Cinematch SM. Its job is to predict whether someone will enjoy a movie based on how much they liked or disliked other movies. Netflix wants to upgrade the system so that they are able to make good recommendations to the new movies and series which come in its platform. The goal of the project is to predict the rating that a user would give to a movie that he or she has not rated yet. I'll be using two error metrics. One is the RMSE value and the other is the mean absolute percentage error. I'll try to provide some form of interpretability with respect to the values which I get from these. This is one of the Kaggle problems. So the dataset was available on Kaggle. It had two main files basically. The first file is the movie titles.csv. It had the movie information in the following format: movie ID followed by year of release and then title. The other file, which being huge in its content, was divided into four different types of files named as combined data 1, combined data 2, combined data 3, and combined data 4. Each of these files contained customer ratings for each movie in the following format: movie ID followed by customer ID followed by the rating given by that customer and the date in which the rating was given. The title of the project would have made it clear by now that what kind of machine learning problem we are trying to solve here. For a given movie and a user, we need to predict what rating would the user give to that movie. So this problem falls under the category of a recommendation problem. The performance metric which I have used to solve this problem is the root mean square error. My goal will be to minimize the root mean square error for this particular machine learning problem. Before building a model, it is very important to understand the dataset. Exploratory data analysis is that phase which will help us to understand the existing user ratings and utilize those ratings to recommend new movies to each user depending on their taste. As this is one of the Kaggle problems, the dataset was obtained from Kaggle. As seen from the example data point, each line in the combined data 1 txt file starts with a movie ID followed by a colon. Then it has a rating from a customer and its date. While performing basic descriptive statistics on this dataset, I came to know that there are around 17,770 movies and 480,000 users currently registered in the Netflix platform. In the pre-processing phase, I merged all the combined data files into one file to perform basic exploratory analysis on that file. The head operation was performed on the merged file to understand the contents of the file and how it was structured. While performing the basic statistics on the merged file, I came to know that there were no null values in my dataset, there were no duplicates, and as iterated earlier, there are around 100 million ratings, 4.8 million user base, and approximately 18k movies on the current Netflix platform. The dataset was then split in the ratio of 80:20 to form the training data and the test data. As I'm here to predict the ratings that a user would give to a movie, so it is very important to understand the distribution of ratings in the training dataset at first. So I created a univariate plot that showed the distribution of ratings in my training dataset. The key takeaways from the distribution of ratings were: more than 25 million customers gave a rating of 4. Approximately three-fourths of the existing customer base rated movies more than 2.
The lowest rating of 1 was given by 3 million customers. So from this we can say that there are around 3 million customers. They were very critical for a particular movie. The time series plot for the number of ratings is as shown in the presentation. As Netflix was founded towards the start of the 21st century, it had a very less user base at that time. But since the inception of 2003, there was a huge surge in the Netflix platform with respect to the number of ratings, as the number of ratings can be increased only if the user base also increases. As Netflix went through a lot of changes during this particular phase, this could be one of the reasons why there was an upsurge in the amount of ratings in its platform. The dataset had no values post middle of 2005, so that is the reason there is a drop in the timescale. Next, I have used the PDFs and CDFs to understand the ratings given by customer. As seen from the presentation, the PDF is right skewed, which means that there were few customers who gave more ratings when compared to others. On an average, each customer gave ratings to 200 movies. But there were also customers who behaved very differently. In fact, one of the users with the user ID 305344 gave ratings to 17K movies. Many questions can be raised with respect to this data point. One of the questions is, does this user really have so much time to watch 17K movies? As we have seen the number of ratings per user, now it's time to see number of ratings per movie. The key takeaways from this plot is that it is very skewed. It is similar to number of ratings given per user. 90% of the movies got some hundreds of ratings. There were only few movies that received more user ratings when compared to others. As I have the date column, it would be very easy to extract the day from it. I wanted to do this to understand on which days of the week the user gives more ratings and on which days they give minimal ratings. The key takeaways from this plot were: customers gave more ratings on Tuesdays than any other day of the week. One strange observation was that during the weekend the number of ratings were quite less when compared to the weekdays. This would normally contradict with the idea that people watch more movies on weekends than weekdays as it is a holiday period. The average rating for each day of the week is as shown in the image. Friday had the average rating of 3.58. The highest average rating was observed on Sunday. In any recommendation problem, the first step is to create a sparse matrix. Creating sparse matrix is very important because processing the data in its original form requires high computing power and time. Now, what exactly is a sparse matrix? It is a matrix where the rows are identified by the users and the columns are identified by the movies. So each cell will correspond to the rating given by the user to a movie. So I've created sparse matrix for both training data and test data. The sparsity of trained matrix is 99.82%. This means that 99.83% of the values are null. So from this we can understand the processing time and efficiency can be improved because most of the values are null. Similar goes with the test matrix. Now from this matrix I calculated three statistics, the basic descriptive statistics like global average, average rating of a particular user, average rating of a particular movie as shown in the presentation. The global average for all movies was observed to be 3.583. For a particular user with user ID 10, the average rating which the user gives to each movie is 3.37. And suppose there is a movie with the name Titanic with movie ID 15. The average rating that this movie has got from each user in the platform who has given the rating is 3.30. Based on these two values, we can analyze whether a movie was a utter flop or it was a blockbuster. Now, as we have the sparse matrix, it would be possible to create a PDF and CDFs depending on the relationship which we want to see. So I've created PDFs and CDFs for two types of relationships: user average ratings and movies average ratings. The key takeaways from these plots were, as you can see from the distribution of users average rating, it is not normally distributed. It has a long tail towards the left. The CDF of this plot suggests that 80% of the users gave rating of less than equal to 4. Now, from the next plot, movies average rating, it can be observed that average rating for a movie is close to 3. This plot also helps us understand that there were around 20% of the movies that performed very bad. I mean, they had a rating of less than equal to 2. So, Netflix had around 20% of the movies in its platform for which the users gave a rating of less than equal to 2. This slide is one of the highlight features of how Netflix operates. After creating a sparse matrix, I have created a movie similarity matrix based on a cosine function. There are many methods available to create a similarity matrix like Pearson method, cosine method, etc. As of now, here I have used the cosine function. Now let's see, for an example, there is a movie Vampire Diaries having a movie ID as 67. The similarity matrix will return the top 100 movies which are similar to this movie. As seen from the image 4, I have returned the top 10 movies, the head of top 10 movies. The first movie is the Modern Vampires, the second is the Subspecies, the third is the Dracula. So, as we can see from this matrix, the movies are closely similar to the Vampire Diaries. I've also created a similarity graph to understand what is the similarity index of the top 100 movies. As seen from the graph, the top 100 movies had the similarity index of greater than equal to 0.10. Let's see the potential problems which I faced while analyzing this problem. While computing user similarity matrix and movie similarity matrix, I faced the following problems. As the user base in the Netflix platform is large, computing user similarity matrix was not at all easy. It would be easy if I had a computing power which was very high and I had a lots of time in my disposal. Even when I tried to do it in my Python notebook, my system used to get crashed because of the data which was so huge. An alternative way which I found was to compute the user similarity depending on whenever it is required. Like suppose at a runtime I require a similarity for a user with ID 1. I will compute at runtime the similar users for that particular user. The same goes with movie similarity matrix. I had around 17k movies in the platform. So only the top 10 or top 100 are taken into consideration while recommending such type of movies to a particular user. So this is the problems which I faced while I was solving this problem. As mentioned earlier, this recommendation problem can also be solved using regression, one of the techniques which I'll be implementing later. For regression, I extracted 13 features out of the 3 data variables which I had initially. The 3 data variables are user ID, movie ID, and the rating given by the user to that particular movie. The 13 features are as follows. The first feature is average rating of all the ratings. The next 5 features are For a particular movie, what are the top 5 similar users who rated that movie? The next 5 features are, for a particular user, what are the top 5 similar movies rated by that user? The last 3 features are user's average rating of this movie, and rating of this movie by that user. I have extracted features both in my training data and test data. Owing to less computing power, I had to sample the training and test data before training the model. As the data set was huge, I mean, it almost had 82 billion records. So, to train the model for all the data which I had, it would be very difficult with the system which I had it in place. It will require a lot of processing power and time. So, I sampled the data in order to train the model on my sample data. The models which I applied are XGBoost, baseline model from Surprise package. Surprise package is a package which has a lot of recommendation algorithms in it. Then I tried to combine XGBoost with initial 13 features and Surprise baseline model. Then I implemented a Surprise KNN baseline with user similarities and movie similarities. So these are the 5 models which I tried to implement. Also, because of the sampling, RMSE values would be high because the models are not trained on actual data. The RMSE values are bound to be high. This slide depicts the results which I got after modeling the sample data using XGBoost and baseline model from Surprise package. As seen from the images, the RMSE values for XGBoost was 1.076 and for baseline model it was 1.073. The baseline model performs slightly better than the XGBoost. One question which comes to our mind is, why is the RMSE greater than 1? The reason for that is I applied this model to train on a dataset having 10,000 rows and 1K movies. When I train this model, and once the model performs pretty well, I can use it on the actual data to get the results if I have a good computing power. That is the reason why the RMSE values are more.
In this slide, I tried to combine the XGBoost with the initial 13 features along with the Surprise baseline model. The test results obtained were RMSE value was found to be 1.076, and as you can see from the graph, the most important features were user average, movie average, followed by the other features. So this is what is obtained from this particular model. The final 2 models which I implemented were Surprise KNN baseline with user similarities and the Surprise KNN baseline with movie similarities. The test results obtained were the RMSE values for user similarities was found to be 1.0726 and for movie similarities it was found to be 1.0727. Slightly user similarities performed better compared to movie similarities, but those two are different context to compare with. Let's see the final conclusions and the recommendations, like how this project can be extended further. Based on my exploratory data analysis and predictions, I make the following conclusions. 25 million customers gave a rating of 4. Approximately 3/4 of the customers rated the movies more than 2. More ratings were observed on Tuesdays than any other day of the week. Movie similarity matrix was very helpful in recommending new movies to the users depending on their taste. This is actually the crux of the Netflix engine. Only few movies were rated heavily by users. That is, they were quite popular. Movies like Titanic. From the start of the year 2003, Netflix was completely changed. It had more user base and more movies in its platform. KNN baseline user similarities performed quite better than most of the algorithms. Due to less computing power, I created models using 10K users and 1K movies so that they can be trained, and later on, after the model is built, I can apply it on the actual data. Due to this reason, my RMAC values were high. In order to extend this project, I would use the cloud computing services or use parallel computing so that I can use my trained model on the actual data to get the results which I wanted. These are the references which I have used in order to prepare this presentation. Thank you.